In April 1943, a German engineer stood at the Kummersdorf Proving Grounds, Germany's top weapons testing facility, his hand tracing the hull of an American tank. This wasn't just any tank, it was War Daddy 2, serial number USA 3067641, captured in Tunisia. The U.S. had called it War Daddy 2. German High Command wanted to understand its weaknesses, but what the engineer discovered was something far more profound. For 3 weeks, he meticulously examined every component. The welds, for instance, were not merely strong. They were clean, uniform, and clearly machine-made. It wasn't just a manufacturing philosophy that struck him. It was the realization that while Germany was crafting individual masterpieces, America was mass-producing with an efficiency that was truly groundbreaking. War Daddy 2 had been captured largely intact, and remarkably, it started on the first try. German recovery teams drove it over 200 miles across the desert to Tunis, a 4.5-day journey with no breakdowns. It was then shipped to Germany for a full evaluation. The engineers at Kummersdorf, who had famously evaluated the Soviet T-34 and helped design the Panther, initially approached the Sherman with a sense of superiority, expecting crude workmanship from a nation new to modern tank warfare. They expected sloppy welds, brittle steel, and a design they could easily dismiss. Instead, they found a tank that challenged their every preconception. Its armor, though not as thick as a German Tiger's, was adequate. But it was under the hood where the true revelations began. The Continental R-975 radial engine, a 400-horsepower aircraft power plant adapted for armored use, immediately impressed them. It offered a power-to-weight ratio comparable to the much larger Panther. More critically, every major component was easily accessible through large hatches. Oil changes took minutes. Spark plug replacement required no special tools. The Americans had built a tank that could be serviced in the field by any mechanic with basic training. German tank engines, in contrast, often required factory-trained specialists and specialized equipment. Then there was the sound, or rather, the lack of it. When the powertrain ran, the German engineers were used to the screaming whine of spur gears. The Sherman hummed. It used herringbone gears, precision-cut helical teeth that meshed smoothly and lasted for thousands of miles. German tanks used cheaper spur gears, which wore out quickly. The Sherman's transmission could handle 3,000 miles before needing an overhaul, while a Panther's final drive often lasted only about 100 miles. A Sherman could drive from Normandy to Berlin. A Panther often struggled to make it from the rail yard to the front lines. The engineers were further astounded by a small box attached to the 75mm gun, an electrical gun stabilizer. The Americans had integrated a gyroscopic stabilization system into a mass-produced tank. While not perfect, it kept the gun roughly on target while the tank moved, allowing the gunner to fire accurately within seconds of stopping. German tanks needed 10 to 15 seconds for their suspensions to settle. This innovation meant the Sherman could get a critical first shot off much faster. The German engineers calculated what it would take to replicate this system. Their conclusion? They couldn't, not with their industrial base, material shortages, or precision manufacturing capabilities. In June 1943, War Daddy 2 was brought to Hillersleben for a demonstration before the High Command. A climbing test on a steep, sandy slope was set up. The German Panther roared up effortlessly, its wide tracks biting into the sand. Then came War Daddy 2. Its narrower, rubber block tracks, designed for road marching, slipped. The engine whined, the tracks spun, and the tank slid backward. The generals applauded, convinced of their superiority. However, the engineers saw a deeper truth. The Panther won the sprint, but they knew it couldn't survive the marathon. The Sherman, despite failing that specific sandy slope, had just driven over 200 miles across the Tunisian desert without a hitch, a feat the Panther rarely matched. The hill climb, tragically, reinforced the wrong instincts for the German military, encouraging them to continue building high-performance thoroughbreds rather than reliable workhorses. Even Albert Speer, the Reich Minister of Armaments, examined War Daddy II. He studied the reports and talked to the engineers. Speer later wrote that reports from Italy praised the Sherman's cross-country mobility, climbing mountains German experts considered inaccessible. He realized that Germany was building complex machines requiring dedicated rail networks, while America was building a mobile force that could drive itself to the front line. Speer understood that no amount of German engineering genius could overcome America's superior logistical philosophy. The Sherman wasn't just a tank, it was a philosophy. American industrial philosophy prioritized reliability, maintainability, and mass production. German philosophy prioritized technical superiority. American designers accepted a less powerful gun because the 75mm was reliable and ammunition was plentiful. They accepted thinner armor for reduced weight and improved mobility. They embraced simpler designs for faster production and easier maintenance. Germany, caught in its own strategic and ideological constraints, simply couldn't compete. As Alfred Rubel, a German Tiger I commander, noted, the Sherman was like a reliable civilian car. You pushed the button and it started. With the Tiger, there was always a procedure, constant worries about maintenance. By 1944, German armored divisions reported operational readiness rates of 35 to 45%, while American units consistently maintained rates above 85%. The Normandy campaign laid bare these truths. During the retreat, nearly half of all abandoned Panther tanks were destroyed by their own crews due to mechanical breakdowns, not combat damage. Imagine the frustration, having the most powerful gun and thickest armor, yet being stranded while a column of inferior Shermans drove past to win the war. The engineers at Kummersdorf had seen this coming in April 1943. They had documented every advantage the Sherman offered, explaining why American mass production would win the logistics war. But their warnings were largely unheard. Germany's challenges went beyond engineering. Strategic materials were scarce, precision tooling was lacking, and their production culture, centered on skilled craftsmen, couldn't adapt quickly enough to American-style assembly lines. Even Nazi ideology, which championed Aryan technical superiority, prevented an honest assessment of American methods. America built 49,324 Sherman tanks during the war. Germany built approximately 6,000 Panthers and 1,347 Tigers. The production ratio for medium tanks alone was nearly 8-to-1. A Tiger might destroy 5 Shermans, but 6 more would arrive tomorrow, and the Tiger would likely be broken down, awaiting parts. War Daddy II had shown the German engineers exactly why they would lose. A tank that started with the push of a button, a transmission that lasted, an engine easily serviced. Reliability beats perfection. Availability beats capability. Working beats superior. Every single time.